Here we go. For scissors, 2 standards. First, sharpness. Second, durability. Sharpness is grindable, but durability is a tricky material issue. Today's theme is clear. We will follow Niels to forge an unbreakable Damascus. Raindrop steel scissors. For materials, we use familiar 1.5-0 and 10.95. 10 stacked pieces. The 1.5-0 here is high carbon steel with nickel. It increases hardness. And after acid etching shows silver patterns. The higher carbon 1095 creates dark patterns. After quenching, it gains great hardness. This white powder is borax. It melts at high heat, forming a protective layer to prevent forging issues. After the heating rounds, lightly use the power hammer. Once fully fused, we can stretch it out. This takes time. To ensure quality, Niels monitors the heat. Reheat when necessary. After reheating, the second forging round is much faster, since we confirmed the fusion is solid. Now for normal scissors. A 20-layer steel bar is enough. But this time, Niels wants a raindrop pattern, so more layers are needed. The more layers, the better the pattern. The stacking process is very simple. Hot cut the steel, split it in 2, and stack it again. Then forge weld it. Once again, for good quality, a bit of borax and wire brushing are essential. After reaching 40 layers, Niels wants more, so he folds it to 80 layers. There's a small detail here. Once the 80 layers are set, Niels anneals the steel. This softens it, prepping for the raindrop pattern. As for the raindrop pattern, how is it made? It's quite simple. After marking many spots, Niels uses different drill bits to drill dents. Various sized holes, just like this. Then reheat the drilled steel. The forging goal is to flatten these holes. This way, the patterns around the holes appear, forming raindrop shapes. During this, the steel must be stretched until it becomes suitable for scissors. Next, Niels uses a grinder to cut along the middle, splitting it in 2, then forge them separately. Scissors are basically dual-blade, cross-cutting tools. They don't chop like axes. They rely on the sheer force between the 2 blades to cut materials. Don't think of it as 2 knives chopping down. The blades press, and slide together, creating high pressure along the contact line to cut the material. That's why scissors don't need razor sharpness to cut cleanly and effectively. Specifically, this involves blade interaction, including blade angle, curve, contact pressure, action position, and edge fit. If these mechanics don't work well together, you'll find some scissors look sharp, but can't cut well. Old tailor scissors may look dull, but cut thick fabric easily. So for Niels, to forge scissors is always a very tough task, because good scissors need more than just sharpness and durability. They need proper mechanics. Now, Niels has finished shaping both halves. Next, based on the marks, he will forge the handles. The handles matter too, after all, based on basic physics. Longer handles need more torque and better leverage. That's why bolt cutters and hydraulic shears have very long handles. Of course, these don't need to be that long. Just a proper length and an ergonomic frame. That is, the handles match grip and finger size for a perfect fit. Besides the handle, the blade angle needs proper adjustment. After some work, the handles are done. Next up are the blades. First, do a round of traditional grinding to remove forging marks, flaws, and burrs. Now, we are very close to real scissors, but the problem is these two handles are misaligned. Real scissors have their handles on the same axis. So Niels works the inner side to grind the blades. In theory, half the thickness is removed, so they align on one axis for a smoother feel and look. Niels blends the handle and blade transition. Once ground, he needs to drill the pivot hole in the middle. The next step is the blade edge. Scissor edges don't need to be beveled on both sides. A single bevel is enough, because scissors don't split. They shear between two blades. If both sides are beveled, they'd act like a wedge, pushing the blades apart. With the structure done, it's time for heat treatment. First is normalizing. After heating, let it cool slowly. After all the forging, the internal grain is very uneven. Next, a hot iron heats the quench oil. This step is dangerous and bold. For the quench, Niels only does the edge. This is selective hardening. It gives different areas, different properties. Also, this step ties to a crucial next step. What step is it? We'll see shortly. Of course, the handle is also quenched. Finally, bake the scissors. To temper, trade some hardness for toughness. Next is that crucial step. Using these 3 molds, give the blades a slight bend. Now you know why we didn't fully harden the blades. If fully hardened, they would likely snap right here. This deliberate bend ensures both blades press together like a spring. This way, when closing, the blades don't touch fully. They form a moving contact point from base to tip. When materials enter this point, they are sheared. The bend amount matters. Too straight, it won't cut. Too bent, it jams. So good scissors need the perfect bend for optimal spring tension. What's happening now? Is the final sanding? The smoother it is, the better the etched pattern will look. This is ferric chloride, a common acid etch. It eats the steel surface. Different steels etch at different speeds. This reveals the beautiful Damascus pattern for a better finish. After etching, do a light sanding. Next, for the handle openings, Niels uses matching copper wire to wrap them. Using hemp rope here would look unique too. For the pivot pin, he chooses copper to match the handle. Niels will use a sharpening jig to sharpen the scissors. With sharpening done, these unbreakable Damascus raindrop scissors are finished. That's it for this video. Thanks for watching. Don't forget to like and subscribe. Bye for now. Thanks for visiting Max's shop. Bye.